So hello, today we'll be talking about capacitor circuits. At the end of this lecture, you should be able to calculate the equivalent capacitance of a network of capacitors connected in series and parallel, determine the total charge, the charge on, and the potential difference across each capacitor in the network given the capacitors in series and parallel, and to solve problems involving capacitors and dielectrics in contexts such as, but not limited to, charge plates, electroscopes, batteries, camera flash lamps, Geiger counters, and coaxial cables. So let's get started. So electrical circuits are often um, electrical circuits often contains two or more capacitors that are grouped together and attached to an energy source such as a battery. And here are the most common electrical circuit symbols. We have the battery with its a single cell battery, so yung longer one, that would be your positive terminal, and the shorter one is the negative terminal of the battery. And here is the ground, the symbol for the ground, which is usually connected to the negative side of your battery. And you also have the capacitor, which is like just an equal sign, right? When you connect capacitors in series and capacitors or other devices that are connected along a single path. So you have a clue there, single path that is said to be connected in series. And the charges in a series connection is the same since inside charge is only induced. So this is an important relation. In a series connection of capacitors, the charges are the same. So the Q total or total charge in that circuit, QT or Q is equal to Q1 is equal to Q2 is equal to Q3. How about the voltage on the capacitor in series? Since the potential difference between points A and B is independent of the path, the battery voltage V must equal the sum of the voltages across each capacitor. So here the voltages are not the same but are the sum of each other capacitors. C1 has a voltage of V1, C2 has a voltage of V2, C3 has a voltage of V3, and therefore the total voltage, you just need to add those and you will get V, or the total voltage, is equal to V1 plus V2 plus V3. So let's have let's calculate for the equivalent capacitance in series circuit. So remember, the general formula for capacitance is charge per unit of voltage. Isolating V from this equation, you get voltage is equal to charge per coulomb. And remember that the voltage in a series connection, they just add, right? So the total voltage is the sum of V1 plus V2 plus V3. So plugging this here, you will get QC is equal to Q1 over C1 plus Q2 over C2 plus Q3 over C3. But remember that the charges or Qs in a series connection are the same, right? Qt is equal to Q1 is equal to Q2 is equal to Q3. So they will just cancel in this equation. Therefore, the equivalent capacitance in series is just the sum of the inverses. Okay, so the inverse capacitance is equal to the inverses of the individual capacitance. Or if I will show you this one, what does this equation means? So going to my iPad, so you see here that 1 over CE is equal to the sum of the individual capacitors C1 plus C2 plus C3 and so on and so forth. Ci. That is the meaning of that summation. Going back to the presentation, how about capacitance? Let's have some example. For example, with the given circuit, so here is your circuit. Across each capacitor, determine the equivalent capacitance, the total charge, and the individual charges, the total voltage, and the individual voltages across the capacitor. So let's proceed to the screen. But before that, take a look at this circuit. So let's first look for the equivalent capacitance. Alright. So here you have given, which is C1 is equal to 2 microfarad, C2 is equal to 4 microfarads, C3 is equal to 6 microfarad. And you are looking for the equivalent. Equivalent capacitance. But remember the equation for the equivalent capacitance sa series. So na-inverse siya, no? So I just need to add 1 over C1 plus 1 over C2 plus 1 over C3. So solution natin, I just need to substitute everything. 2 microfarad plus 1 over 4 microfarad plus 1 over 6 microfarad. Okay? And that's just 1 over CE. So copy natin to. Copy. So yeah, so this is our working equation. Then you just need to plug in your calculator. So when you plug this one in your calculator, you have you just need to add this 1 over 2 plus 4 plus 6, and you will get 1 over 12. Is that the right thing to do? Of course not. Okay, this is the wrong way to solve it. Remember, this is fraction. Okay, so you need to individually add this. 1/2 plus 1/4 plus 1 over 6, and you will get 11 over 12. So 1 over CE, or the equivalent capacitance, is just equal to 11 over 12. But you are looking for this capacitance, so you need to invert or raise everything by -1 to get just CE. So mababaliktad lang siya, 12 over 11. And the unit of this one is in microfarad because hindi naman natin siya kinonvert. Okay, so microfarad pa rin. Or that is approximately equal to, so inverse natin si 12 over 11, lagyan na natin dito, is just equal to 1.09. So approximately 1.09 microfarad. So that is your equivalent capacitance for the circuit. Okay? It's 1.09 microfarad. Alright, so let's talk how about for the total charge. So remember yung charge natin. So going back to the screen. So remember the total charge is just equal to Q1, Q2 to Q3 for a series connection, right? Remember for the capacitance is equal to QT over VT. Okay? So we are solving for the total charge to get everything, right? So QT would be equal to CE times VT. So you will get a VT from the given, which is 24 volts, the total voltage. So you will get 24 volts. And remember, kanina yung capacitance natin, equivalent capacitance natin is 1.09 microfarad. So, yeah. Substitute mo lang siya here. So, 1.09 microfarad. So, that's your QT. Therefore, your charge would be equal to, plugging in sa calculator natin, 1.09 times 24 volts. That's 26.16 microfarad. So, hindi ako nag-convert. So, this is also equal to, you can also write it this way, or 26.16 times 10 raised to negative 6 farads. I mean, not farad because it's charge, right? Coulombs. Microcoulomb. And this will become coulombs. Okay, so that is the total charge. And therefore, you can say that Q1 is also Q2, Q3 are the same, 6.16 microcoulomb. Okay, so that's how we answer this type of problem. Now, how about for the total voltage and individual voltages? So we all know the total voltage. VT is equal to 24 volts. Saan po galing si 24 volts? So nandito siya sa ito, the battery 1. Okay. Yeah. So we are looking again for the individual voltages, because remember, the voltages in a series connection, VT is equal to V1 plus V2 plus V3. Okay, V1 plus V2 plus V3. So we are now calculating for the individual voltages. Okay, so we all know that it's 24, but remember, a total. So how can we solve for the individual voltages? So remember that capacitance is charge per unit of voltage. So V is equal to Q over V. And from this relation, you can say that the voltage is actually equal to QT over V. No, over C, right? From this one. So pinagbaliktad ko lang to. And you'll get V, Q over C, right? So C1 plus QT, C2 plus QT, C3. Because series connection yung charges natin are pare-pareho lang. Okay? So what would happen here? So palitan natin to. Resize. Okay. So going back, what is our QT? So remember, yung QT natin na nakuha kanina is this one, 26.16 microcoulomb. So you get 26.16 microcoulomb over C1. So balik tayo sa problem. C1 is 2 microfarad plus 0.16 microcoulomb plus 26.16 microcoulomb. Then C2 is 4 microfarad. C3 is 6 microfarad. Okay. So here, hindi ko na siya kinonvert into times 10 raised to negative 6 times 10 raised to, coulombs or so because pareho naman silang micro. So, okay lang. Makakancel rin naman yun. And still, makukuha natin is in terms of voltage. Okay? And meron naman tayong way para ma-check yan kung tama yung sagot natin. Okay? So, yeah. So, VT is also, so yung V1 natin, so this is our V1, this is our V2, this is our V3. So, V1 is equal to, so 26.16 divided by 2. That's 13.08 volts plus 26.16 divided by 4, you will get 6.54 volts plus 6.16 divided by 6. That's 109 over 25, which is 4.36. 4.36 volts. So this is your V1, V2, and V3. So nasagot na natin yung tanong. Total voltage, individual voltages. Now, so talaga bang equal yan or approximately equal ba yun sa 24 volts? So yan yung titingnan natin. Alright, so VT. So pag-add natin sila lahat. So 13.08 plus, this one. No, this 3. Kung equal ba talaga siya sa 24 volts. So that's another way of solving it, right? Plus 6.54 plus 4.36. And that is equal to, rounded to the two significant figures, it's almost 24 volts, right? So tama yung sagot natin. Okay? Yeah, that's how we answer capacitance in series. So going back to the presentation. Yan. So tama naman yung sagot natin, di ba? So nakuha natin yung equivalent capacitance 1.09 microfarad. Yung total charge 26.2 or 16 microcoulombs, and total voltage na 24 or V1 13.1, V2 6.54 or 55 plus 4.36 or 37 approximately equal to 24 volts. Okay? Now how about capacitors in parallel circuits? So capacitors which are all connected to the same source. So here, if they are connected like this, so connected to the same source, this is connected to this source, this is connected to this source, this capacitor is connected to this source, all are connected to the same source of potential, and they are said to be connected in parallel. And sa parallel circuit, yung voltage naman ang pare-pareho because they are connected to the same source. Total voltage is equal to V1 here, V2 here, and V3 here. Samantalang si charges naman dito ang nag-a-add. Okay, so total charges is equal to Q1, Q2, plus Q3. Okay, or the sum of the individual charges ng capacitor. Okay, and for the equivalent capacitance, so remember our general equation for a capacitance is charge per unit of voltage, and that is just isolating Q. You will get Q is equal to the capacitance times the potential difference V. So we know that in a parallel plate, parallel connection, Q total is equal to Q1 plus Q2 plus Q3. But remember that Q is also equal to CV. Therefore, CV is equal to C1V1 plus C2V2 plus C3V3. Pare-pareho sa voltage sa parallel plate capacitor because in a parallel connection, because yung mga capacitors natin ay same source. Okay, na-connect sa same source, right? And therefore, the equivalent capacitance is just equal to this summation, or pwede natin express like this. So, CE is equal to, sa ano to ha, sa parallel capacitors in parallel connection. So, C1 plus C2 plus C3 dot CI. So, ilang sinasabi nung summation. Okay, so going back to the presentation. Yeah. This and this. Alright. So, let's try to solve this problem. So, with a given circuit across each capacitor, determine the equivalent capacitance muna. Okay. So, let's go to the equivalent capacitance. So, we all know that, yeah. What is the formula for equivalent capacitance sa parallel? So, equivalent capacitance sa parallel is just the sum of individual capacitors, capacitance of the capacitor. So, C1 is 2 microfarad plus, yan, plus 4 microfarad plus C3, which is 6 microfarad, and that is just equal to what? 6 plus 4 is 10 plus 2, 12. So, 12 microfarad. So, that is your equivalent capacitance sa parallel connection natin. Okay? Easy. Now, how about for the total charge? So, ayun, nakalagay na pala dito. Q total is Q1 plus Q2 plus Q3. Tapos yung mga voltages natin ay equal sa parallel connection. So, let's try to solve for that. So, VT, no? Ay, QT pala. QT. Sa QT is equal to Q1 plus Q2 plus Q3 sa parallel. Right? Sa parallel. So, how do we get the total charge? Remember that the equivalent capacitance is equal to QT over VT. So, do we know the total charge? The total voltage. Yes. It's still 24 volts. Okay? Yung source natin na battery. And so, here, isolating Q, because we are looking for QT, right? To get the total charge, QT is equal to CEVT. Ano tong CE na to? Equivalent capacitance. VT is the total voltage. So, equivalent capacitance natin from here is 12 microfarad times total voltage natin is 24 volts. Dito yung battery. 24 volts. And you will get 12 times 24. So, our calculator is your best friend here. 288 microcoulombs. So that is your QT. That is your QT. Yeah. Okay. And so, yeah. Yeah, you can box your final answer. Okay. So, nakuha mo na sa total charge. Now, let's look for the individual charges. Q1, Q2, and Q3. So, Q1 is equal to CE over V1. CE. Because remember, so balikan natin nga yung equation. Kasi capacitance is Q over V. And you are looking for V. V is equal to Q over C. V1 is equal to Q 1 over C1, right? Dapat ganyan. But remember, we are not looking for the voltage. We are actually looking for the individual charges. So, yeah. Q is equal to CV. So, magiging ganito siya. Q1 is equal to C1 is equal to C1 V1, Q2 C2 V2, Q3 C3 V3. But remember, sa parallel connection ng capacitors natin, voltage natin is just para-pareho. Okay? VT is equal to V1 is equal to V2 is equal to V3. So, ito ay pare-pareho lang na VT. C1 VT, C2 VT, C3 VT. So, madali na siya, no? Substitute lang natin lahat sa ating equation. So, what would happen would be C1 is just 2 microfarad. C2 is just 4 microfarad. C3 is 6 microfarad. Yeah, 2, 4, 6. And the total voltage is 24 volts times 24 volts times 24 volts. Yeah. To get the individual charges. That should be equal to what? 288. Okay, so ito yung pang-check natin. So, try natin siyang i-plug in. 2 times 24 would get 48, right? Microcoulombs. Here, 24 times 4, you would get 96 microcoulombs. 6 times 24, that's 144. So, i-add natin siya. Dapat si QT is malapit dun sa 288. So, 48 plus 96 plus 144. So, 288. Eksakto. So, tama yung sagot natin. So, ito yung Q1, ito yung Q2, ito yung Q3. And ito yung Q total. So, nasagot na natin lahat. Okay? For the total charge and individual charges. Now, how about for the total voltage? So, we all know the total voltage. VT is 24 volts. Ito pa rin naman yung kanina. Iba lang yung type ng connection. So, individual voltages sa parallel is pare-pareho lang. V1, V2, V3 are all 24 volts since it is connected in parallel, or the capacitors are connected in a parallel circuit, parallel manner. Okay? Yeah. 24, V1 is 24, V2 is 24, V3 is 24. So let's proceed to the presentation. Back again. Alright. Okay. Yeah. 12 microfarad. Ayan, tama naman yung ginawa natin, di ba? So, 12 microfarad is the equivalent capacitance. Total charge is 288 microcoulombs. And then, si total charges, individual charges, nakuha natin. Q1 is 48, 96, and 144 microcoulombs respectively. And so total voltage is, again, 288 microcoulombs. For the total voltage, it's just equal to 24 volts because in a parallel connection, The total voltage is the same as the voltages of the individual capacitors. Alright, so yeah, in summary, for a series circuit or capacitors that are connected in series, for the equivalent capacitance, you just need to add the port for you to get the individual for you to get the capacitance, equivalent capacitance, you use this formula, or 1 over CE is equal to 1 over the sum of 1 over CIs, or individual capacitance of the capacitor. Or yeah, and then kailangan mo pa tong i-inverse to get the CE. Kaya ng ginawa natin. Sa series circuit din, yung charges natin ay pare-pareho, pero yung individual voltages natin ay sinasum. Okay? V1, V2, V3 ay iba-iba. Okay? So this is a shortcut to get the capacitance for a series circuit na dalawa lang yung capacitor. Provided that they are two and connected in a series connection, you can use this formula. Shortcut yan. For a parallel circuit, so hindi na giging fraction, naging 1 over CE, hindi ganun. Sa parallel. So as is siya, CE is equal to C1 plus C2 plus C3. So yung sinasabi ng summation na to. And yung charges natin ay nag-a-add. So just add the individual charges na iba-iba sa capacitor. Per capacitor, I mean. And the voltage is the same because in a parallel connection, yung mga capacitors natin is connected with the same source. Okay? Individual capacitors are connected with the same source. So VT, or the total voltage, is equal to V1, is equal to V2, is equal to V3. So, okay, for complex circuit, because hindi naman lahat ng circuits ay simple, for complex circuit, you just need to reduce the circuit in steps using the rules for both series and parallel until you are able to solve the problem. So that's my tip. And that's a tip of the textbook. Okay, that would be all we have discussed about capacitor circuits. Again, this is Sir Mike Angelo A. Aloba, and here are my references. Thank you so much.